If you can hear my voice, I want you to say sha-la-la. If you can hear my voice, I want you to say ding, ding, ding. If you can hear my voice, I want you to say ching, ching, ching. If you can hear my voice, I want you to say sha-la-la. Oh, my high schoolers were so much better. If you can hear my voice, clap 3 times loudly. Okay. Actually, I am so proud of you all. This was good. Shelley, thank you, Shelley. Very good. All right, so we are a social bunch after all, right? Even at 8:30 in the morning on day 3. Okay, got it. All right, very good. So I'd love for someone to share out. Was there convergence in your talk, in your discussion? Was there divergence? Did you learn something new? Thank you, Ned.
Sure. We basically immediately gravitated to how great it is working with NASA, who is very committed to sharing access to getting right into the granules and then visualizing them and helping users get there, because that was a really big part of my career. It's a big part of his. So.
Thank you so much, Ned. One more, and then we've got to turn it over to these speakers. All right, here we go. I'm getting my steps in. Thank you, John.
John Ralph, NCEI. We talked a little bit about the data integrity being sort of implied by the trustworthiness of the provider itself. So they don't necessarily give us the hashes to validate the data, but we believe that NOAA and NASA are giving us good stuff.
Thank you, John. High five. Come on, right here. Thank you. All right, very good. All right, at this time, we're going to go over the agenda for today, and then we're going to turn it over to our excellent speakers. And all right, so let's quickly review. And all right, so here's our lineup. We're going to start with Deborah Smith. Many of us know Deborah over the years. She's going to be talking about the Greenhouse Gas Center, and she joins us from Impact. We have Ned Gardner from NOAA. We're so glad to have Ned here joining us with the camera app. Christopher Hyam, did I say that correctly? Thank you. With the Power Project out of NASA Langley Research Center to talk to us about Power Project's Prove tool. We're excited. Aaron Fries from the Land Processes Stack to talk with us about Pierce. Thank you so much, Aaron. We've got Zong from NASA's Justice to talk to us about the oldie but incredible tool, Giovanni. And then hopefully we'll have some time for wrap up and discussion. So at that point, we will go ahead and open up this presentation and run that. Thank you. Just a second. Okay, and the bio. Deborah Smith leads the Data and Information Portal Operations Team for the U.S. Greenhouse Gas Center operated by NASA's Marshall Space Flight Center. Over 20 years of science research. In 2016, she expanded her adventure to include DAC scientist at GHRC DAC, followed by the project lead for various NASA impact projects, including the Airborne Data Management Group and CASE, the NASA Algorithm Publication Tool, and now the U.S. Greenhouse Gas Center Portal Team. She likes to focus on connecting data producers and developers and data users to ensure effective communication and shared knowledge. Deborah works remotely from Santa Rosa, California, where she gardens at home and camps by the ocean or in forested mountains whenever possible. Jealous.
Yeah.
Brag, brag.
Yeah. Anybody can come to Santa Rosa. We'll open our own center there. It's a beautiful place to live. Good morning, everyone. Thank you for inviting me to speak at this session. I was asked to speak about VEDA, but that's not my expertise. I can speak about how we used VEDA to make the U.S. Greenhouse Gas Center. And I do have to say that anything I present here today is certainly not my work. It is the work of the good people that I lead, and that would be anyone on the VEDA team, which I'm not the lead of because we actually function as two separate teams in NASA Impact in Huntsville, and I lead now the U.S. Greenhouse Gas Center portal team, and I have to emphasize that, and you'll find out why shortly. So I'm just going to quickly cover what each of these are, then go into the visualization and analysis that's available in the GHG Center, and then kind of answer some of the questions I've been asked to mention, and then quickly cover what's in the rest of coming for GHG Center. I'm not awake yet, I'm realizing. Okay, so thank you all for bearing with me. And I wish I had the energy of Elizabeth here, but I will try. So VEDA is the Visualization, Exploration, and Data Analysis Project. It is aimed to create an ecosystem of tools and services that will provide unified open source science infrastructure. And y'all can read the rest because, yeah, this is the standard slide. So my point down here is that it was developed collaboratively by reusing open science components. It is public-facing dashboard. There is a VEDA dashboard if you'd like to go see it. I failed to give you the URL for that one, but I've got the GHG Center in the talk here. It's with data services and visualization tools that one can reuse. And it's designed for reuse, which has been allowing for the rapid application to other purposes, such as the building of the U.S. Greenhouse Gas Center. Also, if you go to earth.gov, that's been built on VEDA, and there's more to come. So there's more people reaching out to use VEDA. It is undergoing a restructure to be able to handle all these implementations. Motivation for the U.S. Greenhouse Gas Center came from the national strategy that was released last December. It says that since the U.S. has pledged to reduce nationwide greenhouse gases by 50% by 2030 and achieve net zero by 2050, an admirable goal. Hope so. Hope we all vote in November. This requires an immediate whole of society approach, including public, private, and philanthropic actors. And to do that, there's an urgent need for distributing the GHG data that we do have that's trusted and scale up all the different advances that we need. And there's a lot of movement right now. I have to say, primarily the portal at this moment is being driven by the needs of the White House. So I've never worked on a project this big. It's kind of scary. If anybody wants my job, let me know. The U.S. Greenhouse Gas Center is, it looks like it here on the left for now. It is constantly undergoing adaptations. I might say that we have lots of people dictating what it can look like. So if you like the kind of job where they tell you what to do and you don't get to put in your own opinion, that's what's going on right now. But you know, we'll end up somewhere, and we've tried to serve too many masters is the problem, and then also we have too many different kinds of stakeholders. Right? How do you get something for the general public and for the scientist in the same environment? If you've got the idea, let me know, because we've battled with this for a year. I started in this project last year. It is a central location for accessing the trusted greenhouse gas data. Our mandate was create a curated, trusted collection of greenhouse gas data and do it quickly. So we started in June. We delivered in October. The site did not go live until November 28th. That's because we sat around waiting for our URL. So once we got that, we went live and we delivered at COP28. I didn't, but you know. And it's from authoritative sources like NASA, EPA, NIST, and NOAA. These are the 4 originating partners who have built this center. It is curated and trusted data sets, workflows, and visualizations, all of it driven by VEDA. And the center is more than a portal. And I have to remind everyone that when we say the U.S. Greenhouse Gas Center, everybody's thinking it's this website. No, it's not. It is this great big group of scientists, researchers, interdisciplinary, everyone who's working on providing the curation and the trusted aspect of the portal. And all we're building in Marshall is this interface for the public and the other stakeholders to see. So the center portal development continues. We're pushing out new this September. We're going to have you're going to go and it'll look different. We have a lot going on and it all goes fast. It's been built in 4 months, as I mentioned. We started with 13 data sets. I hope that's running. Oh, it is, good. I was up late getting it fixed. Its configurable nature of Veda allows it to be a quick portal release. The same thing happened with the Earth.gov. They did the same. They used Veda and managed to do quickly because they used the Veda parts to do what they needed to do. It's a data catalog. As you're seeing, it's a data visualization and analysis that's been combined since this movie. It's science storytelling. Here's one of the stories you're coming up on. It's got content, visualizations of various types, movies, and excuse me, and it's got a compute environment, which I think we're not going to show for interest of time. So we have a hub that you can get access to, but it is by permission. You apply, we check out that the person is real, and then we go ahead and authorize a certain type of entrance for a while to work within the hub and the APIs that are available for the data. We have center visualization tools in Veda itself. It does look like this now. Or is this the old one? No, this is the old interface. We've been really working on improving things. We have here, if you see this little eye right here, I don't know if you can see my little mouse there. It's an eye that shows the, if you click on it, you get the information. It takes you back to the overview page, and I'll be pointing you out to that, out what's on there. And the whole point is to make sure that anyone can get to all the information about the data set, and the fact that it is checked out and validated, and that any data in this center is agreeing with the source data wherever it is. We are not a repository. And people think that. We don't bring the data in and then hold on to it, and people come here for the data. They don't, right? They come to visualize it, they come to get stories about it, and they come to see it on a screen, maybe go use it a little bit with APIs, but we don't hold it. We turn everything into cogs for visualization. So this one is a slider. You can put 2 dates. This is the EPA data. We can pick 2 different dates, go back and forth, and you can see the differences in regulation. Really great example I could show you if I had more time of Texas, and you'd have but before they implemented a new rule there about the oil refineries, and afterwards, and you can see the differences in the data. So there's some really cool things you can look at. We had to specially build some embedded environments. Veda deals mostly with raster in its environment. So we had the need for, station data that collects CO2. That's what you see on the left here. This is Mauna Loa, yep, it is Mauna Loa, with the time series of CO2 in all the years that they've been measuring. You can zoom into that time series, you can pick it apart, you can go to other stations. On the right, we have the emit data, which is great. This is methane plumes. So you're seeing oh my gosh. All right, I gotta go on. I'm too chatty this morning. Don't ask me to explain this. This is Veda. It's made of EO API components, PG Stack, TI Tyler, T Tyler as they say, TPG Stack, yeah, you see it, okay? Those of you who understand this, you get it's components the scientists can visualize through the visualization environment. Here's the data catalog. There's 13. Everything on here, you get some metadata, it's filterable, and then you click on it and boom, you have your data set overview. The overview page is packed. More general at the beginning for the more general user with some metadata information. We right away go to the citation, the version history. It's ordered in a way that makes sense for the different kinds of users so that when people start to fall off, they don't miss information. But I want to point out down here, data stewardship at the end, it's circled in red. It contains a flow of the workflow, how we got it from the data provider, what we did to it, how we validated it, and how it's on the center. Every data set has this. Next, we go to data transformation networks. In notebooks, every data set has what was done in a notebook so that somebody could redo it if they wanted. We have a processing and verification report. It absolutely proves that our data that we're displaying is the same as the data on the repository. And I'm off the stage, get the hook. Notebooks, And here's the important information you all wanted, and we can always flip back to that if we want to discuss it, but I have the answers, it's not much. All right, thank you.
Don't you adore Deborah? All right, we just hit the pause button for a second. We wanted to give the audience an opportunity to ask questions from virtual as well as in
Okay.
person. I see here Ned's got a question.
Thank you for the talk. Sorry you were rushed, but I'm very interested in how we reconcile gridded, sort of an Earth systems perspective on greenhouse gases with like an EPA regulatory perspective about sources of emissions and how power, and if we're looking at a policy level application from the White House, how do you see us reconciling? There's a lot of embedded assumptions in my question, which you're nodding, so I know you understand. So
Yeah.
could you speak to that?
I think you're talking about the top-down, bottom-up, as far as we've got satellite data measuring these and modeling methane and CO2, and then we've got the inventories, right? That's our top-down, bottom-up. We're actually writing a story right now to teach what that differences are, what those differences are. Right now, we do not allow any users to compare EPA to the satellite in the visualization environment. If you choose the EPA data, you can only look at EPA data. And that's per their request, and I understand why. And until we teach more about the differences and have a lot of room for education in there, we don't want that comparison to happen unless you knew what you're doing. So, thank you. Yeah.
Hi, Dave Jones with Storm Center Communications.
Hi, Dave.
I was just, hi, hey Ned. I was wondering, in the site, can you look at various data types and then export them or make them available as a web service or KML or CSV files or things like that, so you can grab them and share them?
In our early Explore environment and analysis, you could make pings of your time series or whatever. Right now, I don't think in the new one there is a way for that. We've talked about adding that back in. And in the meantime, I mean, you can do a screenshot, anything you want, right, to get a picture. But you're right, exporting, not right now, no. You would have to go in through the API to get the data.
Thank you so much, Deborah. The official hook. All right. All right, at this time, I want to welcome Ned Gardner. Ned serves as Program Manager for NOAA's Climate Smart Communities Initiative and the Climate Ready Workforce within NOAA's Climate Program Office. He leads the redevelopment of the U.S. Climate Resilience Toolkit, where federal data, tools, and expertise are packaged to help state and local governments understand and adapt to climate change. He has 25 years of experience studying and communicating about Earth systems. He holds a BA in Anthropology and Environmental Studies from Yale University, an MA in Geography from the University of Georgia, go Dogs, and a PhD in Ecology from the University of Georgia.
While we're bringing up the talk, I'll just say, it's such a pleasure to be here. The first half of my career was focused really on the work we're doing, that this community does, doing data visualization, doing metadata, data management, and we've come a long way in our careers from the kinds of, where do I go now? Okay.
Google Drive.
Okay. And so I am here representing a team of people that are building an application called CAMRA, Climate Mapping for Resilience Applications. And I'm not working with them day to day on the development of this platform, but I am here to reduce greenhouse gas emissions because they are in Arizona and Maryland, and I live in Asheville. But we built climate.gov, we built the Climate Resilience Toolkit on our team. And so we've been focused on how do we get Earth systems data to end users, people who are making decisions. People who are making decisions about climate adaptation in particular, which is a perfect segue from the greenhouse gas talk, because in any adaptation plan at a city or a county or a state, there can be two components. There's mitigation of greenhouse gas emissions, and there's adaptation. Adaptation is the work we have to do no matter what decisions are made about greenhouse gas emissions, because for the rest of our lives and our children's and grandchildren's lives, the Earth system is going to be changing due to climate change. And that's just a fact we have to deal with. So the camera application was developed to provide real-time data and projections. So I want to acknowledge Luann Dahlman, who wrote this talk. She, if you don't, I bet you know her. I bet you know her. Okay, if you don't, you should. She's wonderful to work with. And as was already stated, you know, we not only do we have this huge mandate and requirement to understand and respond to Earth system changes, also I don't have a timer. I have 8 minutes. Okay. Everyone knows about IRA. We have a lot of data. We've a lot of funding right now. Woo! Okay. You know, Elizabeth's a morning person. I can relate. It's okay. So this is a screenshot of the front page, and it's our essential framework is tied in with a larger risk management and decision-making framework called the Steps to Resilience. And that's the underlying architecture for the Climate Resilience Toolkit. It's how we frame the data to decision pathway in climate assessment and adaptation. Specifically, CAMRA is very concerned with the exposure of populations and assets to different climate-related hazards. And so there's a real-time hazard monitoring system embedded in CAMRA. This is all based on an ArcGIS Online architecture, so all the underlying data services are available and traceable for these real-time hazards, and you can trace the source, so that data integrity issue is front and center. Excuse me. There are brief explanations of how to understand and interpret the data. With reduced time, I'm going to move right in here. But we're looking specifically to help people with decisions they have to make. So if we're trying to help people, it turns out urban heat is one of the pressing issues. Heat is the leading weather-related cause of death in the United States. So NOAA is very interested in mapping exposure to extreme heat through urban heat islands and helping people respond. So being able to map the exposure today and tomorrow is very important. So for thinking about tomorrow, we have built an interface to the LOCA 2 downscaled climate projections that were used in the 5th National Climate Assessment. In the 4th National Climate Assessment, this will be updated with the, this is LOCA. We will be updating this with LOCA 2, which was in NCA 5. I'm not afraid of using acronyms in this room. I don't think, does everyone know what the National Climate Assessment is? Yes, okay. So this is so that people can not only gauge exposure, but what is the changing risk profile to heat, precipitation, changing seasons, and so forth. So these data are downloadable and directly linkable to National Risk Index reports so that people can use these data in an assessment for a BRIC grant or other FEMA grants. These data are available in tabular format and map format, so they can be queried directly through data services that you all build and use every day. I don't think I need to explain that, but Elizabeth's first question, what are your trusted sources of information? All of us in our careers, you know, we know to go to Census for Tiger line files. We know to go to USGS for topographic data. We know to go to NASA for satellite information and NOAA for the operational data. So the traceability of those data is implicit in this tool. All the methodologies are mapped out and explained. We are getting ready to, we're in the process of building the back end, the data services underlying these visualization tools so that designers of tools, you, can directly build your own applications. So Dave is going to be serving meteorologists and working with county governments and city governments at building his own tool. He doesn't want it to look like CAMRA because he has a specific thing in his mind, that he knows he needs to build, so we can provide direct access to every instance of a downscaled CMIP6 climate projection and provide that as a data service. That's a pretty big step forward. No problem. So this is part of Kim Valentine's role here, Elizabeth, a larger data management process where we are interested not just in providing a front door and a storefront and putting it on your desk, but giving you the ability to build your own tools. And so I think this is an important step in the direction of going straight to the data service. I think if we kind of look back on how some of the NASA platforms developed with, we have the visualization front end and we have the data services back end, and it's like you're in two different universes. This is trying to build a little bit more of an intuitive way to get to the data services, because let's face it, even those of us who are very technical, also it's nice to be able to quickly visualize what are we going to be working with, and have a discussion with another scientist about why is the spread of this model so different than this model, and why is that important for communication. Being able to evolve those discussions means different kinds of tools, and that's what Camera and Chris together will provide.
Right on cue.
Okay.
Love it, Ned. Great job. You all know the routine. Who's got questions, comments? Oh. Sure.
Hi, I'm Andy Thomas, Earth Science Data Systems Program at NASA. And I just have just two questions. Is that all right? All right, so I may have missed it. How long has the tool been alive? Like, how long has it been in production?
I would say it's been about 18 months that's been online, maybe
Okay.
2 years,
18 months to 2 years?
something like that.
So I know you talked a lot about the people that you built the tool for, sort of the user groups you built it for. So where are most of your users actually coming from? And if you know that, what's the most popular section of your tool?
Excellent
far?
questions. So first, I should say, this tool's been online for that period of time, but we had a predecessor called Climate Explorer, which is not the one built in Europe, but it's the US Climate Explorer. And that's had an evolution over 10 years. And so we learned that initially, when we built Climate Explorer, we had basically the same idea. We wanted to give people an ability to map assets and hazards together and look at impacts, think about impacts. We were a little ahead of the learning curve of that user community doing adaptation work. We have been doing user outreach and research about the people who write plans, the people who make decisions in government, and the people who are sort of the community champions of climate adaptation planning. And what we found is that they've begun to learn how to do the assessment of impact, the assessment of vulnerability and risk. So that's our target. Who comes is a different story. And where we find that it's really our user community that is driving more. We're the ones interested in evolving how we present and talk about these data. We would be happy to get an email from you and provide you statistics and have an actually deep dive about
Awesome.
audiences. That would be a worthwhile conversation. And the second question was?
I think you kind of answered it already, but, or no, actually you didn't. So what's the most popular section of the tool so far in the last 18 months, if you've done analysis on that?
For Camera, okay. And so Camera I kind of featured two different components. There's this real-time hazard mapper. And what we were finding was that has so many bells and whistles. It's so cool. Actually, Dave, you've been working on that kind of real-time tool for 15 years. That front end was taking a lot of our clicks, and actually it's the assessment tool for climate projections that NOAA is very invested in also, because we want people to see their changing risk profile. And so using and accessing that is kind of a different community of practice. Those are people who are interested in climate science and risk assessment. But let's take that up online with Luann, because that's her bread and butter, is understanding users. Thank you for the questions.
Thank you, Andy. Thank you, Ned. We've got a question here from Justin.
Yeah. Hi, I'm Justin Welty with U.S. Geological Survey. And I'm curious, I really like the application, and curious if you have the ability to work with other applications. So for example, we run a project called the Land Treatment Digital Library, which allows researchers in the West to help plan their treatments. And one of the things they're supposed to be looking for is climate resiliency and impacts of climate change moving into the future as they plan these treatments. And what we do with some other projects like this is we actually send them the polygon that they're planning and then return information to our site to provide them with additional information that we don't have directly in the planning tool. And just curious if you have that kind of capability and ability to integrate with other tools, because I could see a lot of applications and potential for this tool to be included in our tool as well.
Yes, we do, and it's a little bit adventitious, a little bit based on who comes forward. So the example I'll provide is from the Forest Service, but USGS, I mean, you have so many potential users that you're directly working with, but I'll talk about Forest Service. They had an executive order requiring them to look at climate change impacts on forests and forest treatment and species management, silvicultural management. So that's required in national forest plans now. They didn't have a quick way to help the different forest unit managers develop these plans. They do have specialists who can analyze climate projections and develop complex analyses of what they imply, but that's like one plan at a time. They wanted to be able to do a lot of them. So they saw Climate Explorer as a tool, which is the predecessor of this, that provided projections quickly. And so we worked with them. They took our code and they made something called Climate by Forest, where they used the polygons of the forests to extract projection data for that polygon, and then come up with an expected change from current conditions set of criteria with t-tests comparing future and present data from the projections. And that was used to then justify, hey, this forest unit is going to undergo a 3-degree on average temperature change. And so it saved them hundreds of thousands of dollars. With a $10,000 investment, they made a tool for the Forest Service based on this. That's really so your question is really underlying the philosophy of what's driving the evolution of Camera and CRIS, because we want you to be able to take the data services and make your own tool. I should also acknowledge that USGS and NASA and other agencies were a big part of the evolution of how we are working with these projections in the Climate Explorer, Camera, and CRIS. So I think this interagency exchange is extremely important.
Thank you, Ned.
Thank you, Elizabeth.
Thank you so much. We appreciate you. All right, next we have Christopher A. Hyam. Christopher's pronouns are he, him, his. He is a geospatial developer for the prediction of worldwide energy resources, also known as the POWER Project, out of NASA Langley Research Center. Although he is located in Washington, D.C. area, he is responsible for building and maintaining APIs, analyzing usage patterns, and integrating new capabilities into the POWER Data Access Viewer. Christopher joined NASA 2 years ago with a GIS background. Welcome, Christopher.
Thank you. Nice. Thanks. Okay. I think I'm in good company here. I'm also a presenter that did not work directly on what I'm about to speak about. But if y'all can bear with me, I'm looking forward to your questions anyway. Hopefully I can answer them. So yeah, Elizabeth mentioned I work for the Power Project, prediction of worldwide energy resources. I'm going to talk about that briefly and then also talk about the Prove tool, which is a new tool we have for data validation for you. And that stands for Parameter Uncertainty Viewer. So we love our acronyms. Sometimes they're a bit of a stretch, but, but there you go. Okay, so the Power Project, we specialize in NASA data, solar and meteorological Earth data products. We customize them for three distinct communities for renewable energy, building efficiency, and for agriculture. Yep, it's free. It's free to anyone to use our services, to access our data. And we have data in multiple temporal levels. So hourly, daily, monthly, and annual, and climatological. So here is visualizations of what each of those look like with some solar radiation data. So we have hourly and daily at the top, and you can see as the time gets longer, the data gets a little bit less noisy for monthly and annual. And this data is really key for our renewable energy users in particular, but also the sustainable buildings and agriculture communities. We also have meteorological, so that's a lot of the parameters we think about a lot: temperature, precipitation, wind speed, relative humidity. Yep, and we have data going back to 1981 for climatological data and back to 1984 for solar radiation data. We're a fairly popular project. We average 10 million or so requests from users every month, and that's 30,000 or so users every month. Recently, we had, last month we had 70,000 users. That was a lot. Yeah, our data is available in many different methods. You can use our application programming interface, our API. We also have data access viewer, a web map, makes it a little bit more accessible for more users. We also have ArcGIS image services, so you can quickly visualize global coverage for monthly and annual data. And all of our base data is stored in the AWS Open Data Registry. That's good for us for saving on costs, but that's also good for you because you can access it directly in there using Python or some other mechanism. We're a very user-centered project, so we hold a global community summit every year now. We're having our third one coming up, so every year for the last 3 years. And we invite all of our users to come to this and share feedback in this forum. But also we accept feedback by email and any other way. Quickly, I'll talk about a use case. So there's this company, Urban Solar. They sell their services to transit agencies. They use power in their models to plan for the worst case scenario. So when solar powered batteries in bus station shelters, planning for when they'd run out, so they can predict and hopefully help their customers avoid leaving riders in the dark at the bus station. And one of their customers is actually King County in Washington, not a place you would think to be a great solar location, but they're running strong. Okay, so talk about Prove now. The Power team, we validate our data against ground station data. We're NASA. We use NASA products that come from satellites. But if you're going to use power, you should have the peace of mind that the data is good, right? So Prove offers an analysis tool to do just that for yourself without having to rely on our documentation as much to do these validations. In other words, Prove allows users at various technical and subject matter expertise levels to validate power data for themselves. For solar irradiance, you can compare power against the BSRN or the World Climate Research Program baseline. And for meteorological data, you can compare against NOAA's ground stations. Prove enables analysis of a single data series or multiple data series and comparing them against each other. The application includes documentation, glossary, FAQs, and also includes an interactive web map and results in tabular format or plot visualizations. We have a few specific tools. So descriptive statistics offers insights to source data arrays one at a time. Comparative analysis allows you to look at two at a time. And like I mentioned before, we have FAQs and other documentation within the application, and we have additional advanced plotting parameters to give you additional insights into your data series. I'll talk about beta limitations briefly. It's a very new tool. It's not perfect. That's where you all come in to give us your feedback, let us know if anything's going wrong. At this time, we only have daily data available for analysis, but we're looking to expand to all the temporal levels. We don't have global coverage at this time. We only have about 15 sites you can compare against, but there will be more. Quickly show my demo. I didn't want to do a live demo for y'all, so here's a recorded demo. Using descriptive statistics, you can look at BSRN, solar irradiance. Yep, so there you can see we have plots and tables depending on which one is most helpful for you. Yeah, sorry, I don't have a QR code for you guys, but we do have a URL listed at the bottom if you want to find that. I also have printed materials out in the lobby. If you guys want to learn more about the Power Project. Here we're doing a comparative analysis comparing power meteorological data with NOAA ground surface station data. And this is the rest I have for this demonstration. It's just the demo's going to run for about another minute, but I'm ready for questions now. Yeah, hi, Ned.
Has the solar industry, the solar power industry tapped into this, for like assessing sites for installations, whether residential or industrial?
That's the plan. It hasn't been released for long. We're still very much in beta. So the short answer is no, just because it's brand new. Power, yes, it's been tapped into a lot by different users for that purpose.
Thank you, Ned. We have time for one more question. Somewhere over here? No pressure? Going once? Oh, here we go. Thank you, Deborah.
Your primary audience, it seems sometimes like it's looking rather technical for an average user. What is your intended audience for this?
Yeah, I thank you for that feedback. The intended audience is for PhD level, all the way down to high school level. Anyone who'd be interested in renewable energy data, really. So it sounds like we have some work to do to make it more accessible.
Thank you so much.
Okay, thank you.
All right. All right, so next up, we have Aaron Fries. Aaron is the Science Coordination Lead for NASA's Land Processes Distributed Active Archive Center, or LPDAC, at the USGS Earth Resources Observation and Science, EROS, Center in Sioux Falls, South Dakota. He has a background in ecology, GIS, and remote sensing. At the LPDAC, he provides insights into user needs through user community engagement and outreach activities and technical support for data archiving, data distribution, and service development. I love this part. Outside of the work, we can find Aaron at dance competitions. Go ahead, Aaron.
Wait.
Okay, it's true. For his two daughters. Okay, not him.
Not me.
All right. Or upkeeping his landscaping at home. Who can relate? Raise your hand. Landscaping challenges. I know. All right. In Fort Myers, Florida. And he shares that it is impossible to keep up with, which I'm sure in the Florida climate. All right, thanks for joining us, Aaron.
Elizabeth, do you have his slides here or? Okay. That's Giovanni.
See how this works out. Thank you very much. Good morning. All right. So, what's up? All right. So I'll be talking a little bit about Appears. It's a web application that's been around for about 8 years, I think. Just talk about some of the visualizations and the quality capabilities that come with Appears. There we go. All right, so Appears is really designed from the beginning to be kind of a low barrier of entry for Earth observation data. Specifically, I mean, it really kind of started off with LPDAC data, but we started to branch out into other data archives. And what it does really is dives straight into the NASA archives and mines the data in place, does some visualizations, performs at archive data reduction. We provide some traceability with regards to where that data came from and what the processes were that were kind of applied on that data. And then also provide some mechanism for reproducibility. It's really kind of a science enabling tool. Lowers the barrier in that you really don't need to have that much knowledge up front about the nuances of the specific data set. So anything with file names or any kind of technical terms that you would see in, say, a CMR or a metadata record, you really don't need to know up front. With regards to workflows, it really kind of shortcuts the scientific workflow, the discovery, the processing. All of that is kind of done up front by Appears. And so it does the accessing. You get some upfront exploratory data analysis to kind of get an intuition about the data. And then it does some pre-processing for you, things like mosaicing, clipping to your area of interest. And then we give you quality information. So that's a little cut off. That's weird. But OK, so there's kind of two pathways within Appears. There's a point sampler and there's an area sampler. The forms are very similar in the information they take, but with the point sampler, you're bringing in your lat-long coordinates, things like maybe Ameriflux towers or what have you. And so with the area, though, then you can bring in either your features or polygons, anything like a shapefile or a GeoJSON file. You can draw in the maps as well. So there's a little bit of an interactive component here. With the forms, we kind of say you bring your where, when, and what, and you get your results back. And so your area, you can specify your time range. So you can bring in a long time range, a start and end date, or you can kind of do a reoccurring time range. So if you're interested in, say, seasonal patterns for specific years, we can kind of make that cut for you. Appears operates at kind of a variable level, so you don't need to bring in an entire file that may have kind of the multiple data sets within it. And so if you want NDVI, you just pull out NDVI. And that happens across the point sampler and the area sampler. Really, at that point, the point sampler is done. You can just submit a request, and then Appears goes and cranks and gets that data for you. With the area sampler, you can get, you have a couple other options. You can get some different formats, GeoTIFF or a COG file, and a NetCDF file that has CF convention applied to it. And then we also do projections. So you can do a few different reprojections of the data as well. There's a couple different interfaces. So you were just seeing the graphical user interface. There's also an API associated with it. So most of our users actually come in through the graphical user interface, but most of our requests into Appears actually use the Appears API. Multiple partners. We pull data from the NASA Earth data, but we do have some external collaborators from the USGS. We grab the Landsat ARD data from the National Park Service as well. We have population data from CDAC, DayMet data from ORNL, and then SNO and SMAP data from NSIDC. These did show up, good. These are just some of the variables. Sorry about the text, it kind of washed out in some of them, but temperature, reflectance from multiple missions, multiple sensors, land surface temperature, veg indices, a lot of land-based, of course, type of variables. We like to show this one because it's kind of, I don't know if it's the moneymaker for Appears, but it really is just a massive data reduction machine. You just don't know how much excess people usually get. But ultimately, we see a 99% reduction in the amount of data that is accessed at the archive versus what is extracted from Appears. And then there's an even smaller reduction in the amount of data that actually gets pulled out of Appears. So through those data visualizations, they're making some determination whether they want to access that data and either do or do not. So that data is staged and kept for 30 days, and then they can pull it down if they want. So that top line kind of represents, we're accessing several terabytes of data, but only a small fraction of that is going out. Visualization-wise, we're going to talk a little bit about points here. We have three kind of tabs when it comes to point, three different kind of comparisons. Just pulling raw data and plotting it on a simple kind of interactive plot here, just doing straight time series on the left side, and then doing kind of stacked time series. Again, I mean, these are not designed to be kind of publication ready and go to your journal and get them in there. They're really trying to get an intuition, explore the data a bit. That middle one is just kind of a comparison. You can compare variables, check out any correlations there. The far right one is more of a categorical comparison. Really brings in the quality component there, so it kind of aggregates the data under the quality classes and tells you kind of how many pixels, I guess, are falling within those individual classes, whether it's good, say bad, or other within those quality categories. For area, there's less capabilities. There's again, exploration. Given the technology that was available to us when we started building Appears, this was kind of the lowest hanging fruit for us. But you still can get an intuition about the data. So it gives you aggregated views of the data. Here we have just the box and whisker plot through time. We were interested in a fire at this time, and you can see after plotting the, say, EVI here, that you have a break in that time series. You can use an interactivity to look at a different variable and zoom into that specific spot to kind of confirm that, yeah, you do have a fire, a scar here. And so that would be maybe be a indication to maybe just download those specific files in Appears. You don't have to download this entire time series. It's just everything's available to you. I think I put this one in to show kind of that these are GIS-ready formats. So COG, NetCDF work in QGIS, ArcGIS, and they're very easy just to stream in any either Python or R environment as well. Data quality. We provide data quality regardless of whether you ask for it. We decode that data quality regardless of whether you ask for it, and so it's there for you. We also provide some additional files just if you want to follow up on or fact check us, really. We provide the source links to the data file, so everything that appears, touches, is provided in those granular lists. We provide a GeoJSON file that has the request available so that you can take that and dump it into another Appears interface and get the same exact request created. So you can share that with your colleague, or you can resubmit a previous request if you had one expire. And then we provide a series of metadata files that give you kind of an idea of what the data went through, gives you the pointers to the data, and then just some caveats or some things to look out with the data that are coming out of Appears. Here's just a CSV file of a point extraction. This is just showing how we deal with quality with the point files. And so you can see the headers here where it's a complete breakdown of the file. So with quality, you usually get an integer data value that has to be converted into a binary, and then you break that binary into some kind of decoder ring classification, and so that's what this is really doing. Area is very much the same thing, but we provide a lookup table. So for any individual data value, we provide that breakdown of the quality so that you can apply that to any quality layer that you get out of Appears. So here again is just that data value and the associated categories for that. I mean, all data is pulled directly from the archive. It is quality checked kind of end to end before it is released to the public at any one time. And so the integrity is there. It's just basically making sure that we are at all steps communicating what that data is going through when we're working with it. There's a link to Appears. Any questions, please feel free to reach out to us, reach out to me if you have any questions, and that's good.
Thank you so much, Aaron. Questions for Aaron? Comments? Who's used Appears? Okay.
Hi, Erin. It's Andy again. So since this tool is a higher level of maturity, I would say, 8 years, are we in operations, or is there a plan to tack on new features or evolve the tool in a specific direction, or beyond LPDAC, like applying the features to other data sets? Mm-hmm. What's the plan?
So we would consider it operational. Adding features is tricky. So we kind of have to make a decision between operations, adding bells and whistles, or adding data sets. We have a relatively small team, and we often choose adding data sets and operational issues, of course. And so new features like more sophisticated visualizations, kind of fall by the wayside in priority planning anyway.
The other part of the question, that might have been 2 parts. So is this a tool that we can scale to other data sets across other DACs?
Yeah. So I mean, we do have capabilities to reach into the ORNL archive and CDAC. Right now, it does access a fraction of the NASA archive, of course. I don't know if it's so much a limitation in capability, but it's more of a time commitment. Like we diligently make sure that that data is plugged in correctly and it's coming out correctly, and we're not distributing any spurious files.
Hi, Aaron.
Hey.
Great talk. Hi, Kat Bevington. I was curious, I know you don't have capacity for adding new features, but I was just curious if you had a magic wand and could add something that would be really beneficial to users. Any ideas on what you would do?
Pre-visualizations. We have a lot of issue with, there's some confusion with, okay, I put this feature on the landscape and I extract data and there's nothing there. Well, it's a couple of reasons why that could happen. Is it no data? Is it that the data doesn't exist? Did I just, and so having pre-visualization capabilities would be fantastic. And I think it would lead to much more efficient use of Appears.
And I want to mention, just a couple of weeks ago, Mike Taylor from Landsat and I went to the Earth Educators Rendezvous, which serves university and community college geoscience professors and instructors. And we did a training on Landsat data with Appears, and the tool went very well. So kudos to all the work that your team does. Very well received.
Hi, Aaron. I have one more question.
Yeah.
So does it handle like level 2 data sets as well?
Depends on your definition of level 2. Okay. The traditional definition, I think, it takes a lot more work to get a level 2 data product in. We have a couple missions coming from the space station that we call SWATH data, EcoStress and EMIT. They have to go through a much more extensive kind of SWAT to grid conversion and testing there. And so within the LP anyway, those are the only level 2 data products that we have in Appears. We have been on our roadmap, we do have a couple others from some other DACs actually, and so we will be kind of exploring those opportunities. But really the way kind of the things work is our science team will come up with kind of a pipeline for what this data should look like when it's going through, say, a Jupyter notebook. This is the expected output. We hand that off to a developer, and then we kind of iterate back and forth. And so we'd work with another DAC to get kind of that kind of setup. What's that?
So the requirement for like converting the non-gridded into gridded comes from the data provider. Is that what you're saying?
Nope, that would happen within the services that support the
Oh, okay.
Appears interface. Yeah.
Thank you, Aaron. All right, thanks so much. Last but certainly not least, our very own Zong Lu.
Didn't test this. They should watch.
It's a hotline. Appears. Here we go. I put it all in. Okay. Right here. Okay. Okay, let me read your, okay. All right, we're welcoming Zong. Zong is from George Mason University and is a scientist at NASA Goddard's Earth Science Data and Information Services Center, or JESDIS. Welcome, Zong.
Okay, thank you very much. Good morning, everyone. My name is John Liu from NASA Goddard Earth Sciences Data and Information Services Center, also known as NASA JESDISC. Yesterday, somebody asked me, what is JESDISC? So I just mentioned that. I would like to acknowledge my co-authors, Benita, James Aker. Benita is here. So I would like to, okay, the title of today's talk is Data Integrity in NASA Giovanni. So Giovanni is an online tool to analyze and visualize NASA satellite and model data without downloading data and the software. So in this talk, I will first give a brief introduction to Giovanni with an example, sorry, no hands-on work. After that, I will present the data integrity challenges in Giovanni. So in particular, the data quality aspect. So here's the outline of today's talk. So NASA JESDISC Giovanni is a popular tool developed by JESDISC in the year of 2000. So Giovanni stands for the Geospatial interactive online visualization and analysis infrastructure. So Giovanni provides the means to perform 22 visualizations on over 2,000 variables in different earth science disciplines and from different NASA data centers. So Giovanni included many weather variables such as air temperature, wind, precipitation from satellite observations and models. So the figure on the left show the numbers of variables in different disciplines available in Giovanni. So you can check the EOS magazine for more details, and information is available on my last slide. So the first thing to do with Giovanni is to find the variables for analysis and visualization. And it is quite challenging to find variables from over 2,000 of them. For example, if you search for precipitation, the result will contain 150 related variables. But Giovanni has different filters to narrow down the selections. So on the left, you can filter the result based on the observations, disciplines, measurements, spatial and temporal resolutions, and so on. So on the right, you can also filter the result based on the data source, temporal and the spatial resolutions. So in this demo case, we select the recently updated Global Precipitation Climatology Project, or GPCP, monthly precipitation version 3.2. So the next step is to select the area of interest. You can choose a country, land, sea, mask, US states, watersheds, and the world regions. So in this case, we select Florida. So after that, we select the time average the map for this case, because we want to see the spatial distribution of precipitation in Florida. So as mentioned earlier, there are 22 plot types for data analysis and visualizations. They are grouped into 5 categories: maps, comparisons, time series, miscellaneous, and vertical. So on this slide, some of them are grayed out because they don't support shapefiles like Florida for the time being. So we select a time period from 1983 to 2020 for this case. So Giovanni will average the data for the selected time period. So here's the output window. It shows the time average the map of the monthly GPCP over the past 38 years. As you can see, the precipitation is not evenly distributed in Florida. So the high precipitation is found in Florida Panhandle. The lowest precipitation is found in the Florida Keys. And you can customize the output. Options are available in the output window. You can adjust the min max and also the color palette. You can select the smoothing or non-smoothing, different map projections. Scaling are also available, such as a linear and a log. And you can change the map decorations and the overlays. And you can also download the data in, download the map in different data formats, such as GeoTIFF, KMZ, and PNG. So the data lineages provide data files in NetCDF for each step of the workflow. So on this slide, it shows the input files used for generating the map we saw earlier. And the lineages still need improvements, such as for open science. For example, the processing code need to be open, available to everyone. Currently, reproducibility is only possible with the links from Giovanni. For example, if you want to share a result, simply copy and paste the Giovanni URL, and your colleague or collaborator will be able to reproduce the exact plot and the data from the URL you send. There are also other options to download the data, and yeah, you can also download the result data from downloads in different formats, including NetCDF, PNG, GeoTIFF, and CAMZ. So limitations. So what Giovanni cannot do, Giovanni doesn't include the data from all 12 NASA DACs. And Giovanni doesn't include the level 2 orbital data, for example, the image on the right, showing hurricane precipitation. So Giovanni doesn't include station data, airborne data, and other instruments such as ground radar network. And the user cannot upload their data for analysis and visualization. Limited data analysis and visualization. As you can see, there are only 22 plot types. Performance can be an issue with high resolution data such as 0.1 degree I-merge precipitation data. So no user preferences are available. So future Giovanni. So the future Giovanni include many upcoming requirements and capabilities such as the FAIR guiding principle, open science, and the NASA data policies. Interdisciplinary research and applications, data integration such as including level 2 data. Yeah, last week I presented some ideas at the International Precipitation Working Group meeting. You know, they were very excited, and they told us it was very ambitious. Okay, and also data privacy, ethics, new and evolving technologies such as cloud computing, AI, ML. Yeah, diverse user community and user experiences such as intuitive, user-friendly data and computing infrastructures, and your feedback is very important to us. As you can see, there are a lot of work to be done. So the data integrity in Giovanni, so challenges in delivering data quality information. So there are two dependencies. External data provider need to provide data quality information such as metadata and variables. And and also for internal dependencies, observational data for evaluation that is missing. And also we need to add more plot types and also workflows like statistics. We used to have some of them, but and for some reason they are not included right now. Yeah, also policy is also very important. Yeah. And also data quality variables such as the I-merge. Right now they only have a relative error, but a lot of Giovanni variables don't have this information. Yeah. Also there should be some guideline how to use this information, especially after you average, for a time period or aggregate, purpose. Yeah. And we need a guidance for that. Also quality information in product metadata, such as uncertain assessment, yeah. Also missing variables and information in the latest DPDG, we also need to revisit them frequently, yeah. Also workflows, yeah, need to be transparent. So also how about the, analysis ready data generated from the, on-the-fly services like Giovanni, yeah. Okay, I think that's my last slide. These are the information for this talk. Thank you very much.
Great job, Zong. Time for questions. 2 questions.
Hi, Andy. I would love to hear more about how you're making Giovanni more fair over time, and I'm just kind of hoping that the dialogue is shared so that other tools in our ecosystem can learn and evolve with you if that's not already happening. So maybe it's more of a comment, maybe there's a way to access that now, but would love to walk that journey with you.
Oh, yeah, actually, yeah, I gave a lot of thought about that. Apparently, Giovanni team cannot do everything, right? We need some kind of open platform, people can share visualization and also, data processing, software, software, fair for software, yeah. I think in addition to data too, ideally, if you have data in Earth data, you can click a button, you can get a visualization without downloading data, that save, egress cost, yeah. You're welcome.
Next question? Comment? Thanks, Ned.
Thank you for the talk. I'm curious if your team has, considering that granules, as the previous talk showed, contain a lot of metadata and supporting layers for QA, QC, and has your team thought about sort of the hierarchy of information in a granule that's implied and why you would want to access one aspect of a granule and in what context? Because like helping someone who is not a specialist in a data set, like myself, let's say, to put a specific data set in context requires going to documentation and understanding a lot of things. So is that an ambition of Giovanni to kind of show in the data development pathway the value of particular data sets and then how it supports maybe the level 2 product or the
well, that information right now is scattered around, as you said, sometimes in the ATPD, in the documentation, people tend to don't read documents, yeah. So, yeah, that's a great challenge, that part, right now Giovanni doesn't focus on that part yet, the data quality, CalVal, yeah, and yeah. That's a very interesting point, yeah. I think right now people are more focused on this direction, provide uncertainty, yeah, quality information, yeah. That's something we need to work with the data product providers, yeah, to standardize this kind of, otherwise it's difficult to scale up, because each product is different, we need a certain, standard, otherwise, it's too much work. And not user-friendly too, especially for interdisciplinary, science, right? Yeah.
All right, last question.
Hi, Dave Jones with Storm Center Communications. This is more of a point of interest because I've heard in various talks folks saying we need to share more data. We need to be able to share it across platforms or get the visualizations out. There is a technology that allows that to happen that is called GeoCollaborate. And it was developed under the Small Business Innovation Research Program, SBIR, which is NASA funded. And it's now at phase 3. So it can be adopted immediately by any federal agency on a sole source basis. So maybe next DSIP will try to do a workshop or something on that because it does work on accessing data from all data portals in a collaborative environment and allows people to get exposed to that data and make sure that they don't spend time on data discovery, right? So you can get that 80% of the work people spend discovering data and put the data in front of them so they can decide whether or not it's useful. So Giovanni would be a great way to interface with it. We just need web services and KMLs, CSVs, and can add other formats as needed, but something that we should talk about more here at ESIP, I think.
Yeah. I really think ESIP can take an important role in this kind of multi-agency, develop some kind of prototype, test bed, Yeah, the other day we talked about the interoperability, yeah. So with this kind of test bed, we can put a standard, and also incentives such as like a visualization, So people can submit their data, just think about the next CDF, yeah. Right now, it's very popular, right? 10 years ago, that was not the case, yeah. All right.
Just, no, keep talking. I'm just gonna.
Yeah, I think something easy can play an important role, in this kind of collaborative, data sharing platform, yeah, because it involves in multi-agencies, yeah, not just one, not just NASA or NOAA, yeah.
All right, before we break, I would love to hear from you. Let me hide this. There we go. So along the lines of Kat's great question. So if funding weren't an issue, you've heard some great tools, some features that they have. I want you to imagine a new tool. What does your ideal tool include with respect to data integrity? What's key? What's most important? Maybe you heard something today that really resonates with you, or maybe you have a whole new idea that comes to mind. Please share that. And as these ideas come in, Benita, Zong, myself, we really are grateful for you joining us this morning. We know it's been a marathon of an experience at ESIP, and committing yourself to an 8:30 session on Thursday is not the easiest. So thank you so much for coming, for your great questions, your participation. Thank you online. Do we have any questions online, Sharif? One question for Zong. Okay.
I think the question was, can you repeat the name of the collaborative portal currently being discussed?
The collaborative portal? Yeah. Geo Collaborate, and Dave Jones is the one that is offering that up. Geo Collaborate. That's great. Thanks so much. Anything else? And thank you, Sharif. Yeah. All right, thanks so much, everyone. Let's take a look. Robust metadata records and usage information, downloadable and citable data, easy interfaces from multiple sources and agencies, human and machine readable metadata, preservation of uncertainty data, real-time trusted data access and sharing across platforms that's inclusive and easy to use. Oh, it exists, Geo Collaborate. Hey. This is wonderful. Would it be helpful to have a PDF of these answers linked? Okay, so after this session, maybe tomorrow, okay, give me a day, I will download these answers and put them on our Schedule. Okay, great. And take a look at the other ones. And thank you again. We appreciate you coming.